Okay, so we're on to shapes. After we did covalent bonding, we're now on to shapes, which is something cool. Oh, I've decided to do 6 special ones for you guys, and I do hope you find this very helpful, and I hope you enjoy this video. Alright, for NH3, nitrogen has 5 electrons in its outer shell because it's in group 5, right? Now, if hydrogen has 1 electron in its outer shell, right? How many do you think nitrogen is going to need to complete its octet? 3, right? So you need 3 of them. So basically, you have N here with 2 electrons, and you have 3 hydrogens bonding to N. Pretty cool. And this would then make the shape here. We would have 1 lone pair, because this is lone pair that did not bond. So you would have 1 lone pair. And you have these bonds forming the shape of a trigonal planar. Not trigonal planar. Trigonal pyramidal. Just for the record, I'm very sorry for the dogs in the background. My neighborhood is full of dogs, and I live in the Caribbean where the windows are always open, so we'd always have that problem. Now you have water. Usually the more electronegative atom goes in the center. So you would have oxygen, which is in group 6, and then you know it needs 2 hydrogen ions, 2 hydrogen atoms. So therefore you would have this going here and this going here. And you form a bond. So therefore we know we have 2 lone pairs. So if we have 2 lone pairs here, we form this shape, and this is known as bend, because we have the lone pairs bending down on the bonding pairs. So we have a bend shape right here. So if sulfur is in group 6, do you think it will form the same thing? Yes, because it's sister to oxygen. Therefore, you will need this going here and this going here. And they would definitely form the same shape, which is here you have sulfur, and you have hydrogen bonding here to give a bent shape. Alright. Now we're going to come on to the more challenging one. Well, the most challenging one out of all of them for you at your level, which is carbon dioxide. Carbon dioxide is in group 4, so therefore it would have 4 electrons, and therefore carbon would need 4 electrons. Oxygen is in group 6, so you could see from this that it would need 2 electrons. And can it get 2 from carbon? Yes, it can. It could get these 2 from carbon, and therefore these 2 would go to the next oxygen atom, right? Here and here. When you have the formation of, when you have something like this going on, basically you just form 2 double bonds, and you see that you have 4 lone pairs, 2 of each on the oxygen atom, and this is linear. So you would have, this is 1 bond here, this is 1 bond here, this is 1 bond here, and this is 1 bond. It's bonding pairs. So you would have 2 bonds, 2 double bonds between each, 1 double bond between each of the 2 bonds between carbon and oxygen. And you would have your lone pair sticking off here to give you a linear shape. And this one is linear. And if you notice, it fulfills the octet where you have 1, 2, 3, 4, 5, 6, 7, 8. So carbon's octet was fulfilled. And let's see if oxygen's octet was fulfilled. You have 1, 2, 3, 4, 5, 6, 7, 8. 8. So it was fulfilled on both ends. So that was pretty cool. Let's try PCl3 and PCl5. So PCl3, P is in group 5. Chlorine is in group 7. So therefore, you would need, well, it was telling you need 3 chlorines at this point, right? So you need 3 chlorines. Right? And from there, because of that, you have this lone pair up there pushing down on these 3 bonds. Like a little bench. You know how a bench is? And we have these 3 things to hold the bench together. Well, that's basically how this is. You have your Cl, Cl, Cl. It pushes it down. And you notice that each Cl has its own 3 pairs of lone pairs on each of them, which lends to its very high electronegativity. And this is known as trigonal pyramidal. And last but not least, we have PCl5, where all the electrons will be involved, and phosphorus is known for expanding its octet. That's why it can do what it is doing right now. So you have 1, 2, 3, 4. I'm making sure I'm spacing out really well. And you have basically a chlorine per each electron. And if you notice, the octet has more than it can bear. 1, 2, well, not more than it can bear, it has more electrons that you've learned. And that's pretty much because phosphorus can expand its octet. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10. Right? And for this one, you have your principal axis sticking out in your equatorial bonds all in the center. Right? So imagine this as a long strap. These are your longer bonds, these are your short ones around here. And I'm going to let you figure out the shape of this one. Let me know in the comment box below. And that's a wrap.